Have you ever wondered how the buildings around you are constructed, the school you go to, or even your own house? Well, that's thanks to architecture that provides the perfect stability for your house and school. Architecture uses both math and science to plan and design buildings as simple as a house or as complex as a skyscraper. The oldest form of known architecture is dated back to the pyramids in ancient Egypt. One of the oldest known architects is Marcus Vitruvius of Polio. Here's Marcus with us today.
Hello. Wow, angles must be precise. Wall length and roof measurements must all be taken and be made perfect, so as to ensure durability and long-lasting structural integrity. It all comes down to the strength, utility, and beauty. A technique used in architecture is the golden ratio. It makes the most pleasing and beautiful shapes. It is also used as a proportional system that deals with two lengths and makes the perfect shape. It's also used in the creation of Parthenon atop the Acropolis in Athens. The ratio is equal to about 1 to 1.68.
Architecture also uses proportion, symmetry, and ratio, as well as calculating area, volume, and dimensioning. Computer programming is an additional software that architects use to construct their buildings in 3D, using the X, Y, and Z coordinates. They also use a fractal, which is a curve or geometric shape, such as used in the Gherkin and the London City Hall. The Gherkin and the London City Hall aren't just used to appeal to the eye, they're also used for environmental reasons. Like the Gherkin has the curve for a reason, to increase ventilation, and in the long run that would help the environment. And the London City Hall allows more exposure to sunlight. In the long run, they are saving energy and helping out the environment.
When designing a building, an architect must take into consideration spatial, environmental, and visual requirements. Some major parts are the foundation, walls, floor, and roof. The foundation is very important as it is what will hold the building, and it needs to be strong. In architecture, there are both live and dead loads. Live loads are mass of people and forces resulting from natural phenomena such as wind, earthquakes, and snow. Dead loads are from the mass of the elements of the building such as the foundation.
The effect of wind pressure on a building is influenced by the shape of the roof and whether the building is open or completely closed. For example, the division of loads on footing. Each pure footing must carry 1/8 of the floor load. The wall must carry 5/8 of the floor load, and the entire roof in the wall load. And that's to ensure structural stability.
Mentioned before, there are other components that must be taken into architecture, and that is pretty much structure and foundation. So one of these things is the roof truss, which looks something like this. The triangle looks a lot better, but it's something around the lines of this. And the roof truss is pretty much a foundation for the roof. But in the rest of the structure, the foundation would be like the walls or before the wood put in to put the walls. And this is an example of it. In this example, trigonometry is crucial to finding out like missing lengths and missing angles. So here we're going to be focusing on half of the triangle like we do in class usually. So it's a right angle. And we're giving the given theta, which would be here 35 degrees. And the length down here would be 20 feet. And the hypotenuse is x, so it's not given and we need to figure it out. So I'm going to flip it over and turn into the basic right triangle. And like mentioned before, this is 35 degrees and this is the 20 feet in length and this is the x. So now we're going to go back to like sine, cos, and tan, which we usually use. So here we need to find hypotenuse, but we are given the adjacent. So a and h would be cosine. So we're given cosine of 35 degrees is equal to the 20 over the x, right? Because the x is not given and the 20 is given. And so now we would solve like a regular equation. And since the variable is at the bottom, we would have to multiply by x to cancel it out. But it's still over here on this side. So now it would be cosine 35 degrees times x is equal to 20. But since we're trying to get x by itself, we would divide the whole thing by cosine of 35 degrees. And so we do that over here too. And then we would get, this would cancel out and we would get x. So now we're going to put this into the calculator. And so it's the 20 divided by the cosine of 35 degrees. And you have to make sure that your calculator is in the degree mode, and it is right here. So then we put enter, and that would be our answer. So our answer would be 24.415. So we're going to round to the thousands place. And don't forget the feet because it's measurement. And now to write it in a sentence, so it's the missing length would be 24.415 feet. And that's how you would solve something in architecture. The difference is that in architecture the problems are obviously going to be more complex, but it all derives from what we do now in class, and it just gets harder from there. But the thing is that it's simpler, and that's how trigonometry is used in architecture.
Oh my gosh, what happened? I thought I had everything. I made a big mistake right now. I better check this.
What are you doing?
I better call them right now. Hello? Yeah. Okay, stop whatever you guys are doing. Yeah, I made a big mistake. One of my calculations was wrong. I better go over there and check. Okay. See you in 20 minutes. Bye.